Pre-Cal, Unit 1, Chapter 1.4, Solving Equations. Sorry my voice is like this, I'm doing my very best. Using 0 to approximate solutions. To use 0, you're going to use your calculator or Desmos. You're going to get your equation to say equals 0 on one side, and then you're going to type it in for y1. So step 1, say y1 equals x cubed minus x plus 1. So in my calculator, now I'm going to hit zoom standard. Anytime it's zoomed in a weird place, you can hit zoom 6 and look at it. The solutions are the x-intercepts. So after I've graphed it, I will use the calculate, so second trace, and then I want to find the 0 where it goes through the x-axis. You'll do your left bound, right bound, enter. And it gives you your 0 is negative 1.32. The next one, to use intersect, if you have something other than 0 on one side, you'll set one side equal to y1 and one side equal to y2. So y1 equals 4x to the 4th minus 3, and y2 equals 2x plus 1. Graph it. And then to find the solutions here, you're going to use the intersect. So you'll do second trace, and this one's option 5. You'll have to move your cursor closer to the intersection point that you want and hit enter. The x value is your solution. So that was negative 0.87. And then you'll have to do it again for the other intersection point. Moving your cursor closer to the one you're looking for. You get 1.12. Solving equations algebraically, you'll use PEMDAS. So I'm going to distribute here on both sides. Get my x's together. I want to get my variables on one side and my constants on the other. To move something, you have to undo what's happening. And then divide by my coefficient of x. Solving quadratic equations, there's a couple ways you can do it. You can do the intersect feature like we did before. You can factor it. This one I'm going to factor. To factor it has to be in standard form, which is ax squared plus bx plus c equals 0. So I'm going to move 12 and negative x to the other side. So what I have is x squared plus x minus 12 equals 0. Now when a is equal to 1, you list the factors of c and find the pair of factors that will add or subtract to give you b. To get 1 and 12 will either give you 11 or 13. 2 and 6 will give you 4 or 8. 3 and 4 will give you 1 or 7. To get positive 1, I'm going to have positive 4 and negative 3. Then I'll use the zero product property, which says when I multiply 2 or more things together and I get 0, at least one of them has to be 0. So I can set each piece equal to 0 separately and solve. So my solution set, and you can write this in set notation, is negative 4 and 3. Factoring this one, it's already in standard form with 0. So I'm going to list my factors of C, 1 and 9, 3 and 3. I need the pair of factors that will add or subtract to give me B, which is negative 6, because my A value is 1. So to get negative 6, I'll use negative 3 and negative 3. So I have x minus 3 times x minus 3. This is also equal to x minus 3 squared. Take the square root of both sides. Anytime you solve an equation by taking the square root, you take the positive and negative square root. And then you add 3. And you get x equals, oh, that's 0, which is positive and negative 0 is still 0. Sorry, I didn't mean to put that 3 there yet. So then now I have my 3, and I have x equals 3. So x equals 3 is my solution. That should be 3. Sorry. The quadratic formula works on every standard form quadratic equation. The discriminant is the part that's underneath the radical, the b squared minus 4ac. If your discriminant is negative, there's no real solution because you can't take the square root of a negative. If the discriminant is equal to 0, then there's one solution. And if this discriminant is greater than 0, then there are two solutions. So on the first one, it's already in standard form. So I'm going to identify my A, B, and C. A is 3, B is negative 5, C is 1. And then I want to find my discriminant first. To find my discriminant, I plug this into b squared minus 4ac. So I have negative 5 squared minus 4 times 3 times 1. It's really important to put what you're plugging in parentheses, because if you don't put this negative 5 in parentheses, it'll give you negative 25, which is wrong. You're saying negative 5 times negative 5. So what we've got here is 13, which is greater than 0, which means we have two zeros. So I'm going to take that and plug it into my quadratic formula. So negative b plus and minus my discriminant there, b squared minus 4ac, sorry, that's a third, all over 2a. I have 5 plus and minus the square root of 13 over 6, which is my exact solution. This can be simplified. My solution set would be 5 plus the square root of 13 over 6, 5 minus the square root of 13 over 6. If you did this one on the graph and approximated, you would get, when you plug these into the calculator, x equals 0.23 and 1.43. It just depends on what the equation is asking, what the question is asking for. If it wants the exact value or rounded. We'll do the same thing with number 7. It's not in standard form, so I need to move that 4x first. And then I'll identify my A, B, and C. Then I'll plug this in to find my discriminant. So B squared, negative 4 squared, minus 4 times A, which is 3, times C, which is 2. And you get negative 8. It is less than 0, so that means there are no real solutions and you don't have to go any further. If you do this one by graphing, then there are no x-intercepts. It does not intersect the x-axis, which would give you no real solutions. We're almost done. Solving radical equations. You have to get the radical by itself before you undo. So this is a cubed root. To undo the cubed root, you cube both sides. You get 2x minus 4 on the left. 2 cubed is 2 times 2 times 2, which is 8. And then you solve this. Divide both sides by 2. You get x equals 6. With radical equations, you have to check for extraneous solutions. So to check that, I'm just going to plug 6 back in and make sure I get 0. So my cubed root is, if I go under math, option 4. 2 times 6 minus 4 minus 2 gives me 0, so that one works. When you have two radicals, you want to separate those radicals first, and then square both sides to get rid of one of the radicals. So I'm going to add the square root of x plus 2 to both sides. Now that I have one radical by itself, I'm going to square both sides. Square root squared on the left cancels. But on the right, I have a binomial, so this is equal to 2 plus the square root of x plus 2 times 2 plus the square root of x plus 2. Don't just square both pieces because of the plus in there. You have to do the binomial. Then you'll FOIL it out. So 2 times 2 is 4. 2 times the square root of x plus 2 is 2 root x plus 2. Square root of x plus 2 times 2, 2 root x plus 2. And then the square root of x plus 2 times the square root of x plus 2 is the square root of x plus 2 squared. Simplify this side. I have 4. I have 2 of the same thing here, so plus 4 times the square root of x plus 2. And then here the square root squared cancels. You have x plus 2. Combine your like terms and get your radical by itself. So I have 2x plus 3 equals 6 plus x plus 4 times x plus 2. I'm going to subtract my 6 and my x to get my radical by itself. So I have x minus 3 equals 4 times the square root of x plus 2. Now that my radical is mostly by itself, as long as it's just multiplication, you can go ahead and leave it like this and then square both sides. As long as we're multiplying, we can distribute that radical here. On this side, you have to FOIL it out. So you have x minus 3 times x minus 3 equals 4 squared times the square root of x plus 2 squared. You get x squared minus 3x minus 3x plus 9 equals 16, and that cancels. Times x plus 2, you're still multiplying there, so that part doesn't just go away. And you have to distribute your 16. Combine my like terms, x squared minus 6x plus 9 equals 16x plus 32. Now I have a quadratic equation, so I'm going to set it equal to 0 and solve it that way. I'm going to subtract 16x and and subtract 32. When I do that, I get x squared minus 22x minus 23 equals 0. This one I can solve by factoring. Factors of 23 that give me 22 are 1 and 23. To get negative 23, I have negative 23. So I have x plus 1 and x minus 23. Use the zero product property to solve each equation. And then don't forget to check for extraneous. The way that I check these for extraneous is I plug them back into one side and make sure it equals the other side. So here I'm going to plug in negative 1. I have the square root of 2 times negative 1 plus 3 minus the square root of negative 1 plus 2. And that should give me 2. If it doesn't give me 2, then it's extraneous, which means it comes out like it works, but it doesn't actually work. It typically gives you a negative under a radical or messes something up there. And then I'm doing the same thing, but this time I'm plugging in 23. And I got 2, so that's my answer. X equals 23. The last question. Absolute value. If A is a real number and if U is any algebraic expression, so U is just something inside, then that means you can split this up and take the inside and set it equal to the positive outside and the inside and equal to the negative outside. I have x plus 4 equals 13, and I have x plus 4 equals negative 13. Because absolute value is distance from 0, so that means in here it could be positive 13 or negative 13, and the absolute value would be 13. So I'm just going to solve both of those. Get x equals 9, and x equals negative 17, and I'm done.